All right, so this is question 1 of the calculator section and part 1A. I have my graphing calculator and this is the actual test that I took right here. All right, so we're supposed to find the 2.25 of the derivative of the function f. So 2.25, it's not on this table, but it's in between these 2 points. Therefore, we can use the average rate of change formula, FB minus FA, B minus A, to find the answer. So basically, we start off with f 2.5 minus f2, and then 2.5 minus 2, which is going to be equal to 10 minus 6 over 0.5, which is equal to 0.5, which is equal to 8. And that would be, the units would be milligrams centimeter cubed. All right. And so in the context of this problem, what this means is that at distance (2.25 centimeters), the density, oh, sorry, I didn't realize, the density of the bacteria population increases by a rate of 8 milligrams per centimeter cubed. All right. Okay. Sorry that my handwriting is a bit messy here. It's kind of hard to write with my phone. Okay. I'll just box the answer, this one. Okay. Question 2 now. Question 1B. Okay. So for question 1b, question 1b, oh, I'm looking at the wrong question. So for question 1b, we're supposed to use right Riemann sum with 4 subintervals. And the formula is that they give us is 2 pi 4 0. I mean, the upper limit is 4, the lower is 0, function r dr. So with right Riemann sum, we start off by, we're going to put the 2 pi in the front because that's what's here. And then since there's an r in front of the function, we're going to take multiply 1 and then the width of 1 minus 0, and then right Riemann sum with the value would be 2. Actually, I think it's best if I write f of 1 here to make it more clear. And then since there's an r, it would be in the front, so that would be 2, and then the width here is also 2 minus 1, and then in the between 1 and 2 right Riemann sum, we would look at f of 2, multiply that by f of 2, and then those are just 2 subintervals. And so for the next ones, multiply 2.5, and then the width between the width of this would be 2.5 minus 2, and then we would multiply that by f 2.5, and then lastly the last subinterval would be 4 multiplied by 4 minus 2.5 multiplied by f4 cubed. All right, and I should say that here the intervals are and since it's right Riemann sum, we would take the right value of each of these blocks. 2.54. All right. And then we would further simplify it. So it'd be 2 pi 1, oh. And then f of 1 would be 2. And then f of 2 is 6. 4 minus 1, times 1.5. Am I missing something? Oh, I missed an interval. Oh, sorry. $2.5, and then that would be 0.5, and then times f of 2.5 is 10. And then there's one more subinterval, which would be for the last one, which would be 1.5, and then 18. Also, I don't know if I mentioned this earlier, the reason that I'm multiplying like our values like 1, 2, 2.5, and 4 from the table is because inside the formula there is an r in front of the function. That's why I'm multiplying it by 2 pi and then multiplying values of r before each subinterval. All right, so now we're just gonna further simplify. Two pi, this would be 2 plus 12, and then since this is calculator, I'm gonna check here. 2.5 times 0.5 times 10. 12.5. All right, plus 12.5, and then for the last subinterval, 4 times 1.5 times 18. Pretty sure. Yes. So it's 108. And then what we do now is that we add all the values in between the parentheses together. Be 2 plus 12 plus 12.5 plus 108. So then, therefore, it would be equal to 2 pi 134.5. Therefore, what we're going to do is we're going to take this value, 134.5, and then multiply it by 2 pi, because that's what's at the beginning of the integral. So what that's going to come out to is 845, which makes our final answer 845.0884. This is the final answer when it's rounded to 5 decimal points, as shown here. This is the full answer. All right, so the last problem on this page is 1C, and it asks if the approximation is an overestimate or underestimate. And it's an overestimation because this function, if we look at the graph, it's increasing, plus we used right-Riemann sum. And when you use right-Riemann sum and it's increasing, that means the approximation is going to be an overestimation. So I'll just write that down. So the approximation is an overestimate in part B, I should write. In part B, all right. Is an overestimation because the function f of r is increasing and right Riemann sum was used. All right. I can try to draw a picture of what I'm talking about. If the function is increasing like that, and right Riemann sum is used, what's going to happen is that it's going to be an overestimation like that. All right. Alright, so part D, this is the last part of question A. I'm just looking at the actual test I took for reference while I explain this. Alright, so here we're trying to find the average value of the function. The first thing we have to do is we find the average value. And the formula for average value is 1 over b minus a, ba, and then I think fx dx. I believe that's the general formula. And so in order to find the average value of the function g, what I'm going to start off with is, so first off, we know that the interval is 1 through 4. Therefore, we start off with, therefore that means the 4 is the b and the 1 is the a. So we're going to do 4 minus 1, and then the 4 is the upper limit and 1 is the lower limit. And then they said GR is equal to this equation. Therefore, we're going to write it here. 16, let me move this a little bit. Cosine 1.57 or and then, all right. And so then what I'm going to do now is I'm going to plug it in. Let me move this back down here. I'm going to plug it in. So I'm going to go on my graphing calculator. Do 4 minus 1. Oh, 4 minus 1. And then go to math. And I'm going to say integral. I know 1 and 4. And then what I'm going to do now is I'm going to input this formula for g of r. And so it's going to be 2 minus 16. And then I'm going to put parentheses, cosine 1.57, and then x. And I'm going to close this. I'll do that. I'm going to go 3. And I'm going to say d of x. So what I got is 9.875794,868. So what I'm going to do is I'm going to approximate that. I'm going to cut that down to 5 decimal places. So it's going to be 9. I'm going to round it. 7, 5, 9.875. 79, I believe. And so what I'm going to do now, so now we have to find a value of k that is equal to the average value on the interval. And so since now we know this is the average value on the interval, the average value of g of r on the interval 1 through 4, we can, in order to find the value of k, we can write g of k equals 9 point, because we're trying to find where k is equal to the average value, which is 9.87579. And so what I can do now is I can go and I can graph, I already have it here. I can graph this function. And, I should probably. Okay, so what I'm going to do is I'm going to go to second calc and I'm going to find the value. And the value that I want to find is where x is equal to this number that we just found. Oh, oops. Am I doing something wrong? Does it have to do the window maybe? Okay. So now what I'm going to do is I'm going to go to, I'm going to try this again. Second calc, I'm going to say a value, and here I want to get 9.875. Actually, I don't know if that's right. I'm not sure actually. What if I do instead, if I go here and I put I can go oh, I think I did it wrong actually. So basically what I did here, let me go back and do this again. I have to go fix what I did here. So basically I'm trying to find for what value K do I get the output 9.87579. So what I did is I went to the Y, and then I put this value, the average value as a line on the Y, as a Y-axis line. And so when I graph G of R, the function, and I have the average value of on the interval, what I can do to find what the value of K is I can go to calc. Let me start this over. And I can go to calc and find the intersection. So I could say that's the first curve and that's the second curve. And that's where this is what K is equal to. Therefore, I'll just write that down. When K is equal to 2.4970169. And this is the intersection of the average value and the function. I'll write a note of that. Found function value line. All right. So yes, so the answer is 2.4970169. All right, that's the value of K. All right, so I'm gonna go back and fix this problem on my original test because I realized I made a mistake. Sorry for the mistake. Anyways, so that is the end of problem 1. Thank you.